this thing gonna work? Yeah. Okay. Není potřeba. Okay, 3 o'clock. Can you hear me okay? No answer. Okay, thank you. Okay. Hello, everyone. I'm Thon. I work for Red Hat. This is a picture of me a few years back. You will note that my age is a power of 2, which sadly doesn't happen very often. So today I'm going to speak about annotation processors. The title says, write yourself an application processor. The first question is, why should you want to do this? But first, before I answer why, I'll have to answer a different question. What is an annotation processor? How many of you know this guy? Oh, okay, one at least. Okay. This is, of course, John McCarthy, the original author of Lisp, the language that pioneered syntactic macros. Of course, syntactic macros were added to Lisp a bit later, sometime in the 60s. Come on in. Oh, more people. Come on, more people. I want more people. Come on, man. This is a good talk. Hopefully. But the idea of syntactic macros is that before your program starts running, macros can do practically whatever they want with the source code, which of course is a bit too powerful for the Java landscape to accept. So we have to live with traditional ways of code generation, thank you, more people coming. We can accept new code generated, but not existing code to be modified, which is very powerful. Some people would also say dangerous. So, can you see these diagrams back there? Okay, thank you. This is how typically code generation works. You stuff some code to the compiler. Code generator will stuff some other code to the compiler. You get some code. You get some compiled code at the output. Annotation processors are very similar. They work a little bit different. You stuff some code to the compiler. The compiler invokes annotation processors based on annotations in the code. Annotation processors can generate new code that will be again stuffed into the compiler, and this can even repeat. And again, you get some code. So this is the basic idea of what an annotation processor is, and I think that if you didn't get it from this, there will be a lot of examples to understand very easily. So why? Do you want to be ordinary program on the right or the wizard on the left? Okay, so this is it's not very serious. Let's get to serious stuff. If you write a program, a larger program typically, you face a lot of problems. And as the fundamental axiom of software engineering says, we can solve any problem by introducing a new level of indirection. And sometimes you also go with except of a problem of too many levels of indirection. In this case, the level of indirection is called compile time metaprogramming. So metaprogramming is like, programs that write programs. The notion of compile time is important here. You can do runtime metaprogramming as well in Java using reflection. So, and I believe that all of us have used reflection at least once or twice. So, why do a lot of stuff that you can do at runtime using reflection, you can also do at compile time using annotation processors. So why would you want to do this? There's a set of reasons. First of all, performance. If you do that at compile time, you don't have to do that at runtime. So leave the work to the compiler. This is particularly important, for example, on constrained environments like Android, where annotation processors are very popular. Come on in. Annotation processors are very, very popular on Android. But it's not only about performance. You can do compile time checking. You can do your own compile time checks, which can be useful. If you are doing a frameworky style development, you might want to check if you use the framework correctly, which you can do yourself during compile time if you write an annotation processors. Typically, frameworks nowadays are based on annotations, so it's not a problem. Also, one nice thing, if you have a code generator, you typically have to plug it somehow into your build system, which requires, usually plugins for Maven and Gradle, maybe, which is a pain to write, at least for Maven. The idea here is that the compiler is the build system. If the compiler finds an annotation processor on class path, on the compilation class path, it will run it. So no build system integration required, which is pretty nice. Let's have a look at some examples, both small and big. There's a nice project by Google called Auto. Has a very nice motto of save time, save code, save sanity. And I'll show two annotation processors from this code, from this project. First one is called Auto Service. If you're familiar with the Java notion of service loader, okay, you know that you have to write a file with name of implementing, whose name is an interface name, and its content is a set of implementation classes, implementing classes, which is, to say it nicely, boring. So you can have an annotation that will generate service loader file for you. I can show that very briefly. Typically, plugin systems can be based on service loader. So you define a plugin interface, which is empty in this case, but that's not the purpose. And then implementation, which would have to either have the service loader file or an annotation. And if I make it compile, can you see that code back there? Okay. Did this thing compile? Yes. And this file is generated automatically. So that's small, but nice. We've got better things. Auto value is is an annotation processor that is a lot bigger, also a lot more powerful. Basically, it generates value-like classes. So you have a class that has a bunch of fields, final fields. It has a toString, hash code, equals, and getter or accessor methods. Writing all that gets pretty tedious. You can have an abstract class that will declare the abstract methods, and the auto-value annotation processor will generate the implementing class with all those toString, equals, hash code methods for you. You will note that I'm referring to the generated class directly in this source code, the auto-value person class, which is possible. There's also a lot more things possible, like you can extend from a class that will be generated by an annotation processor, which sounds weird, but it's sometimes useful. So again, I can show that. I have the person class over here. You'll see that the IDE is screaming at me that it doesn't know the auto-value person class. So let me compile this. And it should be somewhere over here. Yeah. So it got the fields, constructor with checks for null, toString, equals, hash code. So this thing, they've got a new version that is not yet released that can even generate builder classes and things like that. So this one is pretty nice. Why is this thing there? I don't want it. Okay. Yeah, the second one is Dagger. If you do Android development, you have probably heard of Square, a company that is publishing a lot of open source projects. One of them is Dagger, which is a dependency injector based on JavaX inject that does most of its stuff, most of the dependency calculations offline during compilation. So you declare a module. If you know JUICE, then the module concept is very similar. It declares what classes are available, what are the dependencies, and at runtime you will create an object graph from the set of these modules. And if you take an object from that object graph, it will just invoke generated code that knows how to construct that object together with its dependencies. This is actually a project from Square, but Google is doing a lot of development on that as well. So there's a new version of Dagger, version 2, that's being built by Google. It's not yet ready, but it promises to do completely everything at compile time. Butterknife, again, another thing from Square, which does view injection was there some question? Okay, view injection for Android project looks like this. You annotate the fields. The annotation processor will generate code to get these views. And if you call Butterknife inject, it will invoke that generated code, which will set the fields, and you can then use them. Another JBoss logging tools. If you are aware of how internationalization for logging is done in JBoss project, it looks like this. You define an interface with methods. Each method corresponds to a log message. It's got a level, an ID. If you have to do log message IDs, and you can also translate these messages using properties files. And at runtime, you will use that logger declared at the top to log messages using these methods. So this one is pretty nice. some other examples from OpenJDK project. The Java micro-benchmark harness is extensively using annotation processing. This is an example of a benchmark taken directly from their samples. So it's like there are two benchmarks. The first of them is wrong because the value of that log call is never used. So the entire computation can be optimized out. The second one is correct because JMH will generate a lot of code that will prevent things like inlining or dead code elimination. But you have to write the code so that it's possible for JMH to do this. Another one is JC stress, which is a set of stress tests for basic Java concurrency things. So here's another example. It's a class that has a variable x, a field x, and there are two threads that will run concurrently. One will set the x value to -1. The second will set a result to x. A result is then compared to the set of expected outcomes. So this one is really nice in that it shows a strange or maybe a little unknown thing about Java. 0 value is expected because it's the initial value of x. This is when Exter2 runs first. It will observe 0. Second, if the first thread runs and the second observes -1, it's also acceptable. There's also a third state which is also acceptable. All other values are also acceptable because, does anyone know why? Why is it acceptable to also observe other values? Because long and double variables in Java are, or assignment into long and double variables is not atomic in Java. So, etc. There's a lot of other use cases for annotation processors. For example, the Vertex project is using annotation processors extensively in their new version 3. So these were some of the ones that I remembered and that are pretty interesting. So, I want to write my annotation processor. How am I going to do that? Okay, let's pray to the demo gods, because I'll actually try to show you one. I was thinking pretty hard about an example to show you. I got a really nice example. Well, at least I thought that I have a really nice example, but when I went into like 200 or 300 of lines of code and I still wasn't finished, I thought that maybe this isn't the best idea. So finally yesterday evening, I decided that I will show you a very, very stripped down version of auto value, which is boring, but hopefully doable. So, I've got the interface called person annotated with value like, because I know that it's a value like class in that it doesn't change state. It's basically immutable, and I want it to have a name and an age, a set of languages, or a list of languages, and I want it to generate a class that will implement this interface and provide things like auto value, so the accessor methods, the constructor, toString, etc. So I'll try to. Well, I have this mirrored, so I have the code already there. So, is that better? Hopefully better. Okay, so how am I going to do this? I'll create a new generator because the generator here is already complete. So this is the service loader file because annotation processors actually use the service loader mechanism themselves. So I could use auto-service for my annotation processor, but if I did that, I couldn't bash Maven, which I want to, so I'll do it by hand. So an annotation processor is an implementation of the processor interface, which has a whole lot of methods that I really don't want to implement. So I'll instead extend abstract processor. Or maybe not. Yes. And I will provide some metadata using annotations. So I'll copy them from here. So this one is okay. Can you see that? Mostly. You will provide a supported source version, which, contrary to the intuition, is the maximum version that is known to work with this annotation processor. I'm not going to dive into that, but it's something that you might want to read about. And you set a set of supported annotation types, which is the value-like annotation for me. Basically, by this line, I'm saying, hey, compiler, please invoke me and give me all things that are annotated with the value-like annotation. Okay, this is a simple annotation that can only be used for types, which is classes and interfaces, and possibly enums and other annotations. So that's something I will have to watch at. Oh, come on. I'm going to do this. Okay, so the first thing I have is the process class process method. And the first thing I'm going to do is this, because you never ever can throw an exception from an annotation processor. If you do, you will crash the compiler, which is a very instructive experience. So I encourage everyone to do this once or twice, but then please do something like this. So I will do a string writer. And then I will use the processing environment message or print message kind error. If I do a print message with the kind of error, this means that the compiler will present me an error and the compilation will fail. And I will give you a message from the writer to string. So this is basically and I will return false. The return value of the process method is says that you claim the annotation, which means that no other annotation processing should be done on that annotation. You typically don't want to do that, so you just return false. Okay. So I have the processing environment, which will give me some utilities that are very useful for writing an annotation processor. And then with the process method, I also get a round environment, which give me access to the annotated elements that I have to process in this round. As I said, annotation processor can generate code, and on that generated code, another annotation processor will run, which will be the next round. So the compiler will invoke annotation processors as long as they keep generating code. And the moment they don't generate any more code, all annotation processors will be run last time, and that's it. You can actually check for. Oh, this is not what I wanted. Yes, you can actually check if this is the last round by come on, calling is processing over. If this method returns true, then this is the last round of annotation processing. This might be useful if, for example, you are collecting data for all classes that ever come to that annotation processor, and in the last round, you generate something like documentation or statistics or whatever. If you're generating code, you usually want to do that in the very round you get to that class or whatever. So, a lot of speaking, not much writing code. So let me copy this verbatim. So I'll ask the round environment to get all elements annotated with the value-like annotation. Element is like a piece of code that was annotated. If you are familiar with compiler internals, element is basically a node in the abstract syntax tree. So you get all of them, and you do a typical two-step process. First of all, you use the element to figure out what you want to do, and you typically want to put this information in a class that describes what will be done. So first phase will discover information, and the second phase will generate code or possibly documentation or some other thing that might be generated. And you see that I decided to use an exception called can't generate, which has a message and an element. So this is something I didn't tell you above. The print message can accept an element which the error is associated with. And if you do give that element to the error message, the compiler will tell you, hey, this is the place in the code where the error occurs. So if you have an error that is associated with some element that occurred in some specific place in the code, please put that element into that error message. It's highly beneficial. So, first of all, scan interface. I'll probably try to copy some things from here. So what I'm going to do here is I'll check that it actually is an interface, because I said that this can only be applied to types, but it can also be a class or an enum or an annotation actually. So I will check if it is an interface, and if it isn't, I will just use the can't generate exception with an error message that value like can only be applied to interfaces, and I will set the element that this error message is associated with. And I will typecast to a type element, a type element, as you can see in the documentation, represents a class or an interface. In this case, I know that it will always be an interface because I checked for that. I also say, hey, I don't want that interface to extend any other interfaces, so I'll check for that. And I also check for type parameters because I don't want that interface to be generic. So this is like the error messages, the compile time checking that I was speaking about. If you are using the annotation incorrectly, the compiler won't let you. This is very powerful, but also, if used wrong, can be just annoying. Okay, so next, I will collect the information that are necessary for generating the code. So I will look at. I'll get the element utils that give me some utility methods. So I'll get the package in which the interface is declared because I will want to generate the class in the same package. I'll get the name and I'll set and I'll get all the fields. The fields list will be filled in this for loop. Okay, so I've got the interface. I've got the package. I've got the interface name. Okay, 10 minutes. I'll speed up. I take all the elements that are inside the interface, which will be methods, can also be constants. So I'll use the element filter methods that will only give me the methods. And then again, I'll check that the method doesn't have parameters, that its return type is not void, and that it isn't generic. And I'll create my field, which needs a type, which I get from the return type of the method, and a name. And this is how I create the generated class object, which contains all information necessary to generate the class. It's got package name, interface name, class name, fully qualified name on all the fields. I'll do that from the elements inside the constructor. Okay. And then I have the generate class method, which is actually fairly short. So generate class will take the generated class object and the mustache template, which I'll use. It's a simple text-based templating language. And I'll invoke that template with the generated class object, which will be available in that template. So what I actually want to do here a bit more is that I initialize the templating system here, and it should be fine. Okay, and the template that I use here is a package with a package name, public final class that declares all the fields, a constructor, and all the methods, and a toString, and I omitted the rest because I just didn't want to write that. So I got an example here and the main method, and I'll try to compile that. Yeah. So this was actually the code that I wrote here, or copied actually. It shows that the toString method actually does what it should be doing. As I said, and there is a lot more to speak about in this example, but no time for that. So as I said, there will be two phases. First we'll be collecting data. As I said, beware of exceptions. Don't throw exceptions from the annotation processor. Second, if you have an annotation, you can actually get its instance inside the annotation processor, and you can work with it like you normally do at runtime. But if the annotation has a method that returns a class object, please don't invoke that, because you will actually be loading the class, which can have a static initializer. So you are basically running arbitrary code inside your compiler, and you don't want to do this. Third, build a typed model. As I've shown you, I first collected the information, built a generated class object, and generated the code from this class. In this simple example, it's probably overkill, but in larger annotation processors, this is highly beneficial. You don't want to use the element API forever, because it's highly generic, and one can get lost very easily. Tie errors to the elements, as I said. Don't claim the annotations. Always return false unless you are absolutely sure that it makes sense. Second, generating code from the typed model you built. You can use a text-based template like Mustache, which I like. This has a lot of problems. For example, one of the issues with the annotation processors I built is that it will fail. It will generate invalid code if the interface is in the default package. So you can use typed APIs for generating Java code. I'm aware at least of Java Powered by Square and JD Parser by David Lloyd from Red Hat. Testing is actually possible. Google built a bunch of utilities for testing annotation processors. I will quickly show you that this is actually real, because I do have a test that looks like something like this. Assert about Java source that if you compile the book class with the generator, then it will compile without error. Or on the other hand, if I compile a source code that I'll give here as a string, an abstract class instead of an interface, it will fail to compile with this error. So testing is actually possible. Some more resources about annotation processors. And with this, I will close the talk, open questions. And I want you all to go to that URL and say that this talk was absolutely awesome. Thank you. Questions? Very simple. You just put the annotation processor on class path. You just depend on it, which I can show. I've got the example as a separate Maven module, and that Maven module depends on the core, and this is how the annotation processor gets run. And here is actually a commented piece of code that will allow you to debug the annotation processor. So that's sometimes very useful. Another question? Yeah?
Will be the code online?
Yes, I guess. I really don't want you to go into auto value because it is really big. It's a production quality code. So if you want to use something like value, like go to auto value, I can give this very, very simple and problematic code online because it's a lot smaller. So yeah, I will put that online. I'm github.com/Ladislav, and you will find it there. Another question? Okay, we've got, yeah?
Is it possible for annotations to have some dynamic value associated with them, something that would be compiled completely at
If you look at annotations, you will find that the values can only be compile time constants, like primitive types, strings, class literal, arrays, and that's pretty much it. And the reason why, well, at least one of the reasons why annotation values can be only compile time constants is so that you can work with them in an annotation processor. So no, you can't have a dynamically computed value in an annotation.
So isn't that possible to write an annotation processor that will just change the annotation?
No, I absolutely know where do you go with this. Annotation processors are not allowed to change existing code. People from the Lombok project felt disappointed about this, so they broke through the barrier. They are using the internal compiler APIs to modify existing code. So Project Lombok does things like data annotation, which will put toString hash code equals to an existing class. But it's a hack, so you are not allowed to change existing code during annotation processing. And we are out of time, so thank you. Pochopitelně jsem opět zapomněl opakovat otázky.
Myslím, že to bylo z těch odpovědí, to bylo jakože kontext.